Welcome back to API Days India. In this track, we're going to explore the topic of the connected customer and uh, how we connect, how they connect, and different aspects of that. So I'm delighted to kick off this track with a discussion about how organizations evolve. And the organization that Kamalkumar Rathinasamy is going to talk about is the Indian nation. So welcome, Kamalkumar. Uh, I'll
Yeah,
just
thanks,
uh,
John.
I'll just check that you can your slides are showing.
Mhm.
Okay, so this is, I think it's a little bit enigmatic title. So I'm looking forward to learning more. Over to you.
Yeah, sure. Thanks, John. So I'll spend the next 20 minutes to talk about creating a continuously evolving and a learning nation. To just give a probably two-sentence summary of who am I. So I'm Kamal. I'm a principal technology architect with Infosys. I focus on machine learning based solutions, specifically the code generation models, right? Now, this session is about the digital India. Like all organisms in nature, even the digital India need to evolve to get better and better. So the reason being the world is constantly bombarded with signals from markets, governments, and other areas, right? And any system that needs to evolve need to listen to those signals and then respond. Even if our hand accidentally touches on a hot surface of a stove, it moves away immediately before we could even sense that we were in danger. So the digital India, in addition to just responding to signals, it needs to take instantaneous decisions. So that is the gist of this entire talk. And before we see how we go about achieving this entire talk, all the principles, guidance, all derived from this book called The Live Enterprise, authored by Jeff Kavanaugh and Rafi Tarafdar, and published by Infosys Knowledge Institute. That book talks about creating a continuously evolving and learning organization. So we extrapolated that and applied the principles for creating an evolving and learning nation. And that book itself was written based on the experiences of transforming Infosys into a live enterprise. Well, so I'll move on to the next slide. Why do we need to do that? Or even before we say that, what are the themes that guides us to change a perspective and view the nation as a living organism? I'll pick two examples. Number one is a living organism need to provide perceptive experience. Let's take octopus for example. Octopus have 9 brains, right? And one, the central brain in the head, and it has 8 brain at each of its 8 arms. Now, octopus, in spite of being colorblind, because they have neurons in the arms, they can detect photons and change color. That helps octopus to hide from the prey via camouflage. In fact, the image that we have on the left side of the slide, there is an octopus on that image, on that landscape, correct? Because its skin can reflect the surroundings by mapping its environment and merging it on the landscape. Octopus, we can't even see it. I mean, that's the point, right? So octopus was able to do that. In a sense, octopus have the most accurate perception of the exterior world. Now, mapping that back to a living nation, digital nation, right? We need to understand a user, like an environment, like an octopus understanding the wider environment. We need to understand the user thoroughly to provide a personalized experience to the user. Suppose if they're using a digital tool, we need to give them appropriate options to hook them on to the digital tools, correct? So because every user is unique, I mean, they have different ambition, they have different aspirations and strength and so on. They're influenced by the wider environment. So unless we understand the context of the user and the state of the user, we will not be able to perform hyper personalization. Just to emphasize on hyper personalization, Microsoft in a recent study stated that customers have, I mean, this study was related to grabbing the attention for a marketing related campaigns, right? For advertisements and so on. Customers have 8 seconds attention span towards articles. In fact, 1 second lesser than a goldfish, right? So we need to provide hyper personalization really to keep the customer not distracted. So that's one guidance. Second guidance on changing the perspective of a nation and viewing the nation as a living organism is that the digital nation should take intuitive decisions. So our human brain has 100 billion neurons, which together can form 100 trillion connections. So this is called neuron forest, right? They enable brain plasticity. Because of brain plasticity, this brain can make new connections, new neuronal pathways, and they can adapt to any new situation. For example, even if there are few cells in the brain which gets damaged, right? The brain can copy the function from the damaged part of the brain to the undamaged part of the brain, and a trait often found in stroke victims, as you can see it in the image. We need a living organism. If we have to mimic a living organism, it needs to have this trait of adapting to unforeseen circumstances and taking intuitive decisions like how a human brain can do. For example, if a living nation has to mimic this kind of behavior, we cannot program that because we don't know what we don't know, right? So even if it encounters a scenario for the first time, because it can study the surrounding context and the state, it should be able to take a decision with maximum intuition and probably minimum or nil human intervention, right? So we will go on to the next slide to see how do we get there. Okay, we've understood what is needed to become a digital nation, a live digital nation, but how do we get there? There are 6 stages. The stage 1 is connectedness. There are 3 aspects to this connectedness. Number 1, it's about connecting humans, all customers. So we need to provide digital tools to all the humans to perform their tasks anytime, anywhere, so that they all are connected to this ecosystem, to this network, right? So that's one. Second, we need to connect the data. Connecting the data is not trivial, especially if the intent is to connect the data so that we can generate insights from there, where we want to, where the insights can actually drive actions, right? So for us to do that, it's very difficult to connect the data because these data might be stored in different systems, because some might be stored in legacy systems, some might be stored in probably in a modern system, correct? So we need to connect all this data to form an ecosystem so that we can actually use this data to generate insights. One approach that people typically follow is create a knowledge graph that sort of connects different types of entities into one network, correct? The third one is connecting things. Today, all hardware are wrapped by software, like an API, right? So we use API to instantiate a hardware, to monitor its operations, to study its behavior, performance, and so on. Since we use an API to talk to hardware, it becomes technically possible to connect all the hardware, right, via these APIs. So this first step is to connect humans, connect data, and connecting things. Once we connected human data and things, we can observe their behavior, because all these connections, they exhibit, they what do you call, they send telemetry signals. So through the telemetry, each connection can exhibit the telemetry. Through telemetry, we can study the behavior of these entities, whether they are performing the operation, are they being used, are they able to perform their business activities properly, are there any issues in getting the actions done. So we can study the behavior of all the entities in the ecosystem by observing their telemetry signals. And once we observe, right, we can then sense, process, and respond in real time. Once you can, any entity which can sense, process, and respond to signals in real time, that's when it becomes sentient, like human sentience, right? So that's when it becomes sentient. But this is a little tough entity. This is a tough portion to implement technically, right? Because for a non-living thing to exhibit sentience, it needs to take a decision on its own. It can look at the data, it can process the data, but for it to respond to that, it need to take decisions, the intuitive decisions, right? So there are two approaches. Approach one is we can build deterministic systems, the rules-based systems. The rules-based systems which can actually study the data and then probably can take a specific action for a given task. But at complexity and scale, we cannot extend deterministic systems. We cannot write rules-based system for all possible issues that we might encounter or for all possible tasks out there because they are innumerable. The approach two is to build machine learning based systems, the machine learning based recommendation systems, the machine learning based prediction systems. Those kind of systems can look at data and depending on the context, it can take decisions. It's little trickier. Well, it's little trickier because even the machine learning based systems, the difference between your traditional deterministic systems and modern machine learning systems is that in traditional deterministic systems, we need to know the task, we need to know how to get it done, how to derive output from the given input. As far as machine learning is concerned, we probably do not need to know how to generate output from the given set of inputs, but still, we still need to define the tasks. But we are talking about a system which can mimic a human brain in processing signals and generating decisions, right? So that means we are trying to create a digital brain. To create a digital brain, we cannot build a finite number of we cannot build a digital brain which can perform a finite number of tasks. We need a brain like human brain which can continuously learn and evolve, and even if it is tasked with solving a problem for the first time, it should be able to do it fairly decently well without any prior training. Now, I'll take few minutes to explain how the recent trends in machine learning helps us to build such a digital brain. Earlier, the H1 is Horizon 1, earlier, probably 10 years back, since 2014 times when ImageNet got released, right? Since then, if you have to build a machine learning system, it was completely supervised. So it's built for one task. If you have to translate from French to English, right? So that's one task. We need to collect lot of French statements and equivalent English statements, and we need to collect lot of it, feed the bulk training data, and process it. It demands large compute, higher cost, and lot of time. So this is how systems were built 10 years back. But we need systems where it has to in general learn various things, not specifically one task, right? Then since 2017, 2018 times, at least in natural language processing, there has been a breakthrough. They found a new thing called language model. This language model enabled this machine learning team to build something called as pre-trained model. This pre-trained model was not built for one specific task. The pre-trained model was built with a lot of unstructured data, like the text in Wikipedia, probably the cricket scores, the poetry, probably a lot of code from GitHub, and a lot of movie reviews, YouTube subtitles, right? It can just browse through the information in web without a specific input and a specific output, right? Like how a human being undergoes a school and a college education, right? So we go to schools and we learn a lot of fundamentals without knowing where we will apply eventually in the future. So we learn the fundamentals in the beginning stages, right? The pre-trained language models learns all these fundamentals by browsing through the web, and the machine learning engineers can fine tune the pre trained language model for a specific task. Here, when you fine tune, we don't need as much data as we would need for training it from scratch. So we need lesser data. But still, again, here we need to define the specific set of tasks that we want digital brain to operate on, that to excel on, correct? Then came The third generation of machine learning models, this has been popular in the last 2 years, where machine learning researchers were able to build a very large language model. So that means it learned from lot and lot of text, like 1 TB or 800 GB kind of text in the internet. And so without fine tuning them for any task, we can just pick those large language models and we can tell them that, okay, this is the task. And we are going to probably give it as an instruction or probably give 1 or 2 examples to explain what the task is, right? So if we can pick a large language model, and if you can tell the model saying that, like, this is my task, translate from English to French, or complete the code, or this is my data, give me an insight saying whether it is positive or negative, right? So these models are capable of performing those tasks without any prior training. So this advancement in machine learning enables us to build a digital brain because it needs to browse through different kind of information which are not structured, which are predominantly unstructured or semi-structured, where there is no, where they are not labeled, right? So, but the latest machine learning models can learn from variety of data and can help us to build the digital brain. Now, the digital brain for the nation that can take decisions at runtime based on the given input. So, so once you do the digital brain, that when it becomes sentient because it can make the decisions on its own. Now, once you have a system which can take the decisions on its own, also you've connected all the systems where you have a real-time view to the business information. That's when this digital entity, a nation or an enterprise, becomes alive. That's when it's I mean, it's not completely alive like a living organism, but at least this is where it starts appearing to be a living organism to an extent, right? The bare minimal thing to become a living organism. It reached here. But implementing this is not easy. It's not trivial because majority of, I mean, in India, so we have software systems built right from 1980 using mainframes. Then we have software systems built before internet era. We have software systems built during cloud era. Now we have software systems built during mobile era. So there are different kind of software systems which used different technologies, and so it's very difficult to connect all these software systems and form one ecosystem. So that's where the challenge is. And in Infosys, uh, we have actually, this is where we face the challenge because we need to connect all the systems built in different eras, right? So this is where we need to have an agile mindset where we need to reimagine all our use cases and form agile teams and build micro use cases, right? And have probably linear improvements to the system without affecting the stability. But once you have this approach, the output is not a linear, it's a compounding effect, correct? So that's the benefit of actually having such a kind of an agile mindset in building this system, right? So the last step is being innovative. So even in the agile mindset, the key is how do we connect the different systems in an enterprise or in a nation, right? All hardware and all software are exposed as APIs and are shared to every other use case in the organization. So you can actually probably spawn a new machine, activate a new machine or a new VM via API. You can access a particular business process via API. You can access a particular data via API. So you have bundled all fundamental reusable blocks as APIs, and they are available as a shared digital infrastructure for rest of the organization to use. But how did we reach there? Because we reach there because any software solution that we build, and if you have to build a similar solution, instead of replicating it, we unbundle it. So we unbundle the software systems, make them multiple reusable fundamental components exposed as API, and rebundle it. And you continue doing that. We call it dolphining, like a dolphin that swims up and down in cycles, right? So we continue unbundling, rebundling, and unbundling and rebundling to improve our shared digital infrastructure so that it becomes a digital runway for organization to build much more components in the future quickly, right? And this this shared digital infrastructure is not new in India. This is already adopted as part of India Stack, the Aadhaar, the UPI. So all these systems were built with this idea of shared digital infrastructure, and they can be used across to build much more components in the future. So this is the core of what I wanted to present, but I will end with this note. It's understood that it's not easy to become a live enterprise sooner, to become a live nation sooner. It's a long winding road, and it's a journey and not a destination. But the point is, we get better and better as and when we evolve and evolve, right? The nation had a head start of 3.8 billion years, and so our efforts are going to take little more time. Thanks, Joe.
Thanks very much, Kamal. There's a lot to unpick here. Actually, what the first thing that came to mind when you started describing this structure of an organization was another book by Gareth Morgan called Images of Organization. And that outlined that several different ways of visualizing what an organization looks like. And for technical people, we most commonly look at things like a machine. We try to, if you look at a car, it's got a chassis with four wheels and an engine and a steering wheel, and all of these parts connect it together. And we tend to assume that organizations work that way also, and we construct technology stacks, architectures that assume that this part is connected to that part, is connected to that part, and it's all linked, and it just runs that way.
Correct.
But the challenge with that, of course, is it's not resilient, because when the organization needs to change and some function needs to move from somewhere else, or new capabilities need to develop, it's not so easy to simply bolt that on. And this images in organization promoted some other images, like an organism, and you used the analogy of the octopus that has brains in its tentacles as well. So there's a degree of autonomy about what actually has to be done. You don't necessarily need to go back to the center to make a decision. They can make decisions at the edge. Another image was of a political organization. And if you think about a political party, it has different factions, people vote, people form alliances and things. And this also happens in organizations. But the challenge for us as building systems is that we have to be able to build systems that adapt to changes in the not only in the structure of the organization, but also the external environment that we face. And of course, everybody's been adapting for the last couple of years.
Right.
How do you relate that back to something like Conway's law, which we often talk about in API circles? Which Conway's law, for people who are unfamiliar with it, is that organizations who design systems are constrained to produce designs which are copies of the communication structures of the organization. So if you have a retail banking organization, then all the systems seem to be aligned around retail banking. In that, corporate banking section division has a different set of systems. And so, but what you're proposing is a more self-learning approach to this. How do you get managers to let go of some things, though?
Right. So very interesting question, John. Right. So while it is easy to build API for a given environment for a specific task, correct? Because that's where focused, right? We are very clear of the objective, and we can build the API. This is one end of the spectrum. The other end of the spectrum is to build an API such that for use cases that we don't even foresee in the future,
Hmm.
correct? So how do you build an API that where it can be useful for such a kind of scenarios or use cases, because we don't know what kind of use cases we will have 5 years down the line, right?
Yeah.
So there's always a challenge, and it's always a challenge. One way how we have mitigated, at least in our organization, when we transform to live enterprise, is that it was difficult. Even if we plan to build a very generic API, there is a limit to which a human can think, because we all think linearly, but the demands come non-linearly, exponentially, right? So one way is we have a playground where we use that playground to test various different use cases, right? And so once you actually build all those use cases, even if you don't have other use cases, I mean, even if you don't need to build other use cases today, we have a playground where we script and try to come up with various different scenarios. So when we script for various different scenarios just for experimentation, because it's a playground just for
Mhm.
experimentation, right? Where we script and we almost find that most of the use cases are so tight and it's not actually useful to be used outside their domain. See, the domain adaptation was a problem. So the more we experiment, then the more feedback we pass to the use case owner or the API owners, then they make it more and more generic, right? Without affecting the stability. Probably this is
Mm.
what I think how we can
Yeah.
approach this. Yeah.
Mm. Okay. All right. Well, we could talk about that a lot, but thank you very much for sharing that perspective, Kamal.